A very good evening and warm welcome to everybody who's joined us this evening. We trust and hope you're all safe and sound. Welcome to today's launch of ISHRAE's position paper on UVGI. Before we start the session, I would like to read the Code of Ethics. Thank you. In this ISHRAE meeting, we will act with care, dignity, and consideration, upholding all values of trust, teamwork, meritocracy, and justice. We shall not exploit the society's forum for any commercial or personal gains, and shall avoid all real or perceived conflicts of interest, and that our thoughts, words, and actions shall not besmirch the image and standing of ISHRAE. Thank you so much. I would now like to introduce our ISHRAE president, Mr. Amitabh Basur. Mr. Amitabh Basur has a BSc and BTech and MBA in Marketing and Finance from Kolkata University. He has 33 years of experience in HVAC and R with specialization in industrial ventilation and fume extraction systems. He's the Director of Operations at Aircon India Incorporated, a HVAC and R contracting company and one of the leading partners in the country for Carrier air conditioning, Wipro Water, and Canon office automation products with over 450 employees and 60 crores in turnover. He's the current national president of ISHRAE and a committee member of the COVID task force. Welcome, Amitabh sir. I would request you to please address the gathering.
Thank you, Nisha. Thank you for the introduction. Good evening, everyone, and a very warm welcome to the launch of this UVGI position paper. ISHRAE, as you know, today is a family of almost 26,000 plus members, including professional members of about 14,000 and almost equal number of student members. We are spread across 44 chapters, which is 44 cities precisely where we are operating from. And we have our student chapters in 250 plus student in colleges, in engineering colleges. Our foundation of ISHRAE is basically on two platforms, that is technical work and educational work. We do the technical work through technical groups, which we call PGs. There's about 30 odd technical groups. You will hear about them a little more from Mr. Vishal Kapoor, who will be addressing the gathering later. We also do a lot of research which can benefit the industry as well as the fraternity. Currently, we are doing almost 5 projects in research. We have spent more than 2.3 crores in research work. And also one of our main objectives is to develop standards. So those details you will get, as I said, later from Vishal. In education, our main objective is to run certification courses. We have certification courses which are starting from technicians right up to engineers for designing of clean room and so on and so forth. Also diploma courses, which is a 4-month diploma course, which is very good course for students who are just passing out or young engineers, or even to brush up your knowledge base for engineers who are matured or experienced. There are workshops on various topics which can be which are there which in our educational thing. So it's a total basket of education, starting from certification, diploma, workshops, and also skill development in certain areas. So apart from that, our engagement with students, we do design competitions, hackathons, quiz, industry visits, site visits. Our main objective is to connect with the student, is to reduce the gap between the campus and the corporate. We make them industry ready through various programs that we have. And also we engage with this, the students or the kids rather, from kindergarten to class 12, and increase awareness within the children about environmental impact, or how to kind of improve the environment on the climatic changes, and also conservation of energy, and you're kind of using more energy efficient products, increasing awareness on those things, so that we walk into a future generation with more awareness on these areas. uh, of course, ISHRAE also organizes and connects with the industry through one of the largest exhibition on HVACR. It's the sixth largest exhibition in the world on HVACR, which is ACREX, and the largest in South Asia, of course, and also RefCold, which is a large exhibition for refrigeration and cold chain industry. Apart from this, we have a large nationwide conference called Urjavaran, which is not restricted now to the Indian nation. We have gone abroad. We have conducted programs in Bangladesh, in Nepal, in Sri Lanka, in African countries like Kenya, and we are getting very good responses from there. In fact, we have a large membership base from these countries also, apart from the other national programs which are conducted from various chapters. So these are the basic activities of ISHRAE, and today is one of that activities. We keep on doing things. This position paper on UVGI is being launched today. We will have a panel discussion. We'll hear more about it. There are eminent panelists who will be talking on this. And once you download this position paper, you will know exactly that this is a special focus has been given on COVID. So how to kind of eradicate the airborne infection. UVGI can be a good media for that, particularly for existing installations where we find difficult or challenges in kind of improving the filtration or the air dilution methods that are generally recommended. So you will hear more about it in today's this thing. So in the program, and I'm sure that you will enjoy it. It will be quite enlightening for all of us. We are all looking forward. There's very, very strong eminent panelists who will be sharing their views on that. So we look forward to that. And I will request all of you who have not yet joined ISHRAE to come and join this society. I can assure you it will be a great experience. We learn from each other. Learning never stops. It's lifelong learning over here. And once you join, we will learn from you, and you certainly will learn from the wide array of offerings that ISHRAE has got. So look forward to that, and look forward to a great evening. Thank you once again for taking out time and joining. And thanks to the panelists also for giving their time. Thank you very much. Over to you, Nisha.
Thank you, Amitabh sir, for taking us through the many initiatives at ISHRAE. I would now like to invite our ITC chair, Mr. Vishal Kapoor. Could we please have the bio? Thank you. Mr. Vishal Kapoor has a BTech from IIT Roorkee and MBA from FMS Delhi. He's the managing director of Meho HCP Air Systems Private Limited. He's a partner at Environmental Protection Services Company, a firm offering HVAC remediation and IAQ services. He served as the ISHRAE president in the year 2017 and 18. He's the national chair for technical committee, the chair of COVID-19 task force. He's a board member at IEQGA. He's the president of Kolkata Rata chapter. He's the vice chair RAL Financial Support for ISHRAE and the programs chair for IAQA of the India chapter. Welcome, Vishal sir. I would now request you to address the gathering.
Thank you, Nisha, for the nice introduction. Thank you, Amitabh, for taking us through the journey and the plans of ISHRAE and where we stand. And Amitabh talked about the technical activities of ISHRAE, which is amongst the most important objectives of our society, because our society is basically a technical society of individual members. Now, what all do we do in this technical activities? I'm going to be focusing the next couple of minutes around what we call as TGs, or technical groups. Amitabh addressed that we have around 30 plus technical groups which are currently active and doing a lot of work. Now, what are these groups all about? Each group is about a particular subject matter, ranging from basics of air conditioning, heat load, psychrometry, to equipment parts of air conditioning, refrigeration, to applications like healthcare and data centers, etc., to operation maintenance, to air quality, filtration. So each TG focuses on one particular subject matter. The members of those TG, ranging from possibly 6 to 60 or maybe at times a little bit more, are subject matter experts. They are ISHRAE members who are volunteering their time to work for ISHRAE, for the society, for the industry, to help in further development of various activities. What are these activities? Some of the activities would be writing and developing publications, whether they're short position papers like the one we're doing today, or they're detailed guidebooks, like our healthcare technical group is in the process of getting ready a 400 plus pages guidebook for air conditioning and applications in healthcare specific sector, which will be launched hopefully in December this year. Whether they are short guidelines, whether they are fundamentals, various kinds of publications that come on that subject matter. Then they are helping in creating workshops, whether they're short duration workshops, long duration certified workshops, or various kinds of webinars and programs on that subject. Then they get into conducting research. As you heard Amitabha, we're doing close to around 5 active research initiatives right now, partnering with some of the leading institutions across the country in various activities from air conditioning, refrigeration, insulation, etc. We are in the process of developing standards, and these technical groups again help in developing those standards. Today, we've developed standards on chiller rating, on VRF testing and rating, on air handling units, on filters. One of our first standard was on indoor environmental quality, a very, very important current subject. Then we've just recently launched one more standard on commissioning. And there are many more right now in development, for example, in evaporative cooling and cooling towers, etc. It is a continuous process. So these TGs get involved in everything possible technical on their subject, which they are owning. For example, today what we're seeing is a TG which is called a UVGI TG, and the TG has members varying from manufacturers to consultants to applicators to users to academia, so that we get a very well balanced opinion, very well balanced output coming out from these TGs. And what we're doing today, the launch of this position paper, is one step in that direction. All our TGs have been working very aggressively. For example, just recently we launched a position paper, not a position paper, sorry, a guidebook on air purifiers, which was done by our indoor air quality TG. We are in the process now. Next couple of weeks later, we will be launching 2 publications. One is Basics of Air Conditioning, which is meant for people who are just starting their lives or still want to brush up on their knowledge on air conditioning, as well as a white paper on thermal comfort. We will be launching on cooling towers, on air handling units. So there are already 30 plus publications lying with us, and we have many more coming up. Just next week, we have a workshop on insulation being held by the TG who has developed an insulation book for us. So there is a lot of activity being done by these TGs, and we look forward to all of you coming both. If you are a subject matter expert and an ISHRAE member, you can volunteer to serve on these TGs through our website, or you can gain from the knowledge being generated by these TGs. Now, coming to today's subject matter of UVGI and what brought us to form this TG, activate this TG, and this TG thought of bringing out this paper. Now, sometime last year in the month of April, ISHRAE had launched this COVID guideline document, both for comfort application, healthcare, operation maintenance guidelines. When COVID came into being in the early days, everybody was a little confused. People were not sure, including us engineers were not sure on how this virus spreads. And in the beginning, there were remarks against airborne transmission. Then airborne transmission started getting more and more validation, basically saying that, yes, this droplet nuclei can spread if they're 5 microns and lower. Sizes can spread beyond 1-2 meters in the air and can be inhaled by people over there, causing them problems. Obviously, the spread of this virus depends a lot on the physiochemical properties of the virus itself, as well as the temperature and the humidity and the conditions inside the indoor space. But yet, if it is airborne, we need to have strategies to mitigate the effect of this airborne virus. There are a lot of strategies. No one strategy in itself is sufficient. We always talk of combining strategies, and the most important part obviously starts from personal safety, which is mask, the right mask, and more importantly, the right fit of the mask, because there's no point wearing a mask which is not fit properly, social distancing, hygiene, etc. And the other intervention technology, which the most important one would be ventilation, as ranked possibly the most important one to ensure and mitigate the spread of this virus. We talk about air cleaning, filtration. We talk of airflow or air distribution patterns, how we how we pick up air, whether it's return or supply or exhaust from those premises. And in that pretext comes UVGI disinfection. UVGI is not a very new subject. It is a very, very old subject. But in the last year and a half, it's come into major prominence because of the virus. and because of a lot of companies and technologies coming around it. And that was the whole purpose of launching this position paper. You will be hearing a lot more about it from the hardcore members of this technical group and other panelists ahead. But I just wanted to give you a background as to what made us bring this virus, this position paper out, basically to arrest and ensure that the right information reaches all of you. So stay online. The next R plus is going to be very interesting for all of you. We're going to be addressing some good controversial subjects as well as giving you a lot of knowledge. So thank you for joining in, and see you later. Nisha, back to you.
Thank you, Vishal sir, for taking us through the details of the TG and how it came about and how it came to be. Before moving ahead, I would now like to introduce Mr. K. Raghavan. Could we please have the bio on screen, please? Yeah. Mr. K. Raghavan is a mechanical engineer with AC and R specialization. He has 33 years of experience in the HVAC and R field. He's the director of channel sales at Johnson Control India Private Limited, focusing on IEQ and energy efficient solutions. He's been an active trainer of Hydcore and EcoFric program under Ozone Cell for the year 2002 to 5. He's a technical committee member of BEE labeling standard for room AV and India chiller standards. He's an ISHRAE member for alternate refrigerants committee, the vice chair for the UVGI technical group, and he's also written a 7-part article series on BMS for HVAC engineers in the journal. I would now request Mr. K. Raghavan to take us through the presentation on UVGI position paper.
Thank you very much, Nisha. Am I audible?
Yes, sir, you are audible.
Okay, let me share my screen. Is it visible?
Not yet, sir. It's visible now, sir.
Okay, great. Good evening to all of you. So today we are going to share some interesting information about how to apply UVGI and really make all our workplaces and public places fully protected from the infection spreading. I am a representative speaker representing the UVGI Technical Committee. So whatever we are going to see in the next 15 minutes, it is all put together by this team of Dr. Nitin Devdar, Dr. Avinash Kulkarni, Bhushan Desai, Rahul Prabhakar, Richi Mittal, and myself. Chandran also has been the guide for our team. Also, I have 13 corresponding members. So this is whatever we are going to see. This has come out of a lot of discussion from this team. About COVID virus, what you see on the right side is an enlarged visualization of comparison of COVID virus with the PM10 dust particle. So the PM10 dust particle is what you see on the extreme right, which looks like itself we cannot see with our eye. We need an optical microscope to look at the PM10. So compared to this size of PM10 dust particle, the coronavirus, which you see the second object from the left side, which usually is in the size range of 0.1 micron and less. So that is the size of virus we are talking about, how we are going to stop it from spreading through the airstream and infecting more people. Could be in our workplace or maybe in a public place. So with whatever available filtering technology, it is very difficult to filter this less than 0.1 micron particle virus. And usually the lifespan of COVID virus is about 6 to 8 days. So the only possible solution, viable solution as of now seems to be applying UVGI in all the HVAC equipment, as well as there are some technologies for taking care of the non-conditioned spaces. Now a quick brief of what is this UVGI, how it is able to neutralize the microbe. What you see on the left side is a light spectrum. The ultraviolet band, which spreads right from 100 Newton meter to 400 Newton meter, is just below the visible light range. So the UVC band spreads from 100 to 400 nanometer. What is of importance, what is of interest to us is the shortwave UVC, which is over the range of 200 to 280 nanometer wavelength. Out of this 200 to 280, the particular wavelength which the industry is regularly using is the 253.7 nanometer, which is the optimum wavelength we are using, though the best effect we get is by using 265 nanometer. So with available manufacturing technology, what we are able to generate and supply is the 253.7 nanometer wavelength. Now, why do we call this UVGI, germicidal irradiation? The reason is, if you look at the right side picture, when any microbe with DNA, RNA molecules is exposed to incoming UVGI, particularly of 254 nanometer wavelength, the characteristic of the UVGI is such that it has the capability to break the DNA or RNA of the microbe. Could be any microbe, could be a fungi, algae, spore, bacteria, virus, anything, everything known to science of any microbe, the UVGI will be able to break the DNA and RNA. Then they won't be able to sustain and they won't be able to replicate. So this is why we call this particular band 200 to 280 as the germicidal irradiation wave band. Now, whatever we are going to see in the coming slides normally is based on using a low pressure UV lamp. So what you see here on the extreme right top corner is a general construction of a low pressure UV lamp. This you can draw similarity to a normal fluorescent lamp that we use at home. So this also use a low pressure inert gas, usually a mixture of gases. And it also use a little iota of mercury atom of less than 5 milligrams. So when this is energized using a special power assembly called ballast, and electric charge starts exciting the low pressure atoms, it hits the mercury atom, vaporizes. That is how it emanates the UVC band of 254 nanometer. Normally we see whenever UVGI is on a blue color light. So actually we are not seeing the UVC light because it is not visible to our eyes. What we see is a very small fraction of visible light wavelength. So that is what we make out of the blue light that is coming from UV lamp. A quick look at the UVGI. Now we will be very much surprised when we look at this chart. The UVGI was known to mankind right from 18th century, 1877, it was first used for water disinfection. During the 1940s, when antibiotics still have not been medically approved and they were not being manufactured in such a large volume, to fight tuberculosis in US and Canada, in the Northern America continent, many schools and public places were using upper zone irradiation unit. So that is very surprising to note. But subsequently, the speed with which the UVGI introduction could have been done, could have been applied in the normal industrial practice, that slowed down. So one reason could be around 1940, penicillin, though it was invented in the 1920s, medically it was cleared for production and a large volume commercial production started in the 40s. So subsequently, the antibiotic development picked speed, and almost for every bacteria and whatever infection was known in those years, the scientists were able to come out with an antibiotic, which was a very cost-effective solution. So that could be one reason why we didn't see UVGI really becoming popular. But when we look at many government agencies in the US, like CDC, EPA, FDA, they all have recognized the benefit of UVGI. There have been a lot of researchers, hundreds of researchers and demonstrations which are published, which are available in the public domain. we still do not have a well-recognized UVGI standard. So ISHRAE is currently working on it. And all this picked up speed only in the last 10 years. The reason why only in the last 10 plus years is now we are seeing emergence of lot of new virus variants, lot of new mutation forms, which becomes very difficult to immediately solve with the vaccines. So the vaccine development also is taking time. So till that time, how do we protect our workplace and public place? And whichever virus spreads through aerosol form, the right approach could be applying UVGI and adopting this in our design practice. Now, let me quickly touch upon some of the key things. We are going to look at applying UVGI and what are the technical features that we should keep in mind while applying it in air handling units, induct airstream application, disinfection. And we also will look at quickly some of the other technologies like upper zone units, portable UVGI units, PCO, and many other emerging products. Starting with the air handling unit application of UVGI, what you see on the right side is something called, which looks like a dirt. This we refer as biofilm. So biofilm is, whenever we know in the evaporator coil in air handling unit, it is all wet because of the dehumidification happening. So whatever microbial presence is there in the airstream, when it comes across this wet surface where some small dust is getting stuck, immediately it starts building its bacterial colony. The CFU starts growing on the coil. The thickness could be just a few millimeter, few microns, or it could be very thick as you see on the visual here. So the right way to judge whether this is a biofilm only is by applying Petri dish or contact swab plates, which you can see in the picture below. So these are simply touched on any surface where we want to verify, is this a biofilm? Is there a presence of pathogen, any microbe there? So within 48 to 72 hours, we will be able to judge, is there a presence of microbe on that surface? So we can touch the coil, the backside clean surface of the AHU coil. We can touch the drain pan. We can hold it in the airstream. So it is up to us how we want to evaluate. And this is the kind of growth we see in 48 to 72 hours, which is a sort of visual proof, which shows that this is a biofilm. By applying UVGI, the biofilm can be totally taken care. And this has been well established and proven to be very effective in air handling unit application. We being from the HVAC fraternity, we understand if the coil is going to be like this with a lot of growth on the surface, it is going to retard the heat transfer as well as it is going to add to the airflow resistance. So though the primary objective of applying UV lamp in air handling unit is to take care of microbe, to disinfect the coil, to disinfect the airstream, it also has an additional benefit of energy saving, which is a different discussion, but I just want to bring your attention to this point. There has been an ISHRAE research project, which came out, concluded that by applying, taking care of the biofilm on the AHU coil by using UVGI, 21% reduction of air pressure drop and 14.5% increase in the overall heat transfer was found. So definitely approximately at least 10% plus we can expect to see energy saving in our HVAC equipment, from the chiller plant, from the VFD pumps, the VFD driven blower motors in the AHUs, etc. One standard question which we face in the field is, where do we put the UVGI? Should it be upstream before the coil, that is in between the filter and the coil, that is called upstream, or should it be downstream? So there are, of course, pros and cons in applying the UVGI upstream and downstream, but the downstream application gives more advantages compared to negative points. So some of the benefits we see by putting the UVGI in downstream is, as this picture depicts, in the space between the coil and the fan. is we get access to the drain pan, because the drain pan also is a source for microbial growth. That is one. Second, once the UVGI is applied in this space, this whole AHU plenum, whatever width is available, space is available, it all gets irradiated, and it also facilitates the possibility of airstream disinfection being affected within the AHU plenum itself. So that is one more benefit. It helps us in interlocking the UVGI with the access door, with the fan power, etc. Next thing is, by putting it in upstream, we will have to be a little more careful about the filter material, because if the UVGI will be in between the filter and the coil in upstream, it could have some material compatibility issue with the filter. So those things we need to keep in mind. We also, by putting it in the downstream, can ensure that there is no leakage irradiation from the AHU UVGI into the AHU room. We will be talking about safety a little later. Now, whenever we are talking about applying it downstream, there is a particular parameter called wind chill factor, which we need to keep in mind. The wind chill factor is something like this. So if you see the right side picture first, the UV lamps, like being a low pressure lamp, like a fluorescent lamp, they all follow a standard rating methodology. Ambient air, this is the output it gives, this is the power consumption it has, and all that. So what you see on the y-axis is the UV output in percentage. So generally at the rated ambient of, let us say 30, 32, 35, whatever is the rating standard. So compared to that, downstream, we know the coil leaving air temperature is going to be in the range of 10 to 13, 14 degrees centigrade. So from 30 plus, if you drop the air temperature to around 10 to 12, we can see the UV output also drops. So this is called the wind chill factor, because the lamp becomes cold, automatically the output drops. So before applying the lamps, we also need to take care of the rating of the lamps and also consult with the manufacturer so that we do not face any performance issue. We go by the manufacturer's recommendation. In the AHU application or in-duct airstream disinfection, we know we are going to face air moving at a particular speed. It is not a still air application. So the left side chart shows how the UVC output changes with respect to air velocity. So these charts also will be available from the manufacturers. So once we understand the application, what velocity we are talking about, what temperature we are talking about, it facilitates us in selecting the right equipment with the manufacturer's guidance. Talking about AHU application, there are two different ways we attempt applying UVGI in AHU. I will first talk about the coil disinfection, because so far across the globe as well as in India, generally we have been very familiar applying UVGI for coil disinfection. So it comes with a parabolic reflector at the back side of the UVGI, as you can see on the left side bottom photograph. So in a narrow convergent angle, it is illuminating the coil, exposing the coil to UVGI radiation, which is also pictorially depicted in the above picture. Now, the distance between the coil and the UVGI location, usually we go by the manufacturer's recommendation, who will be having either a software to select or a Excel calculation sheet. Now, if you move the lamp very close to the coil with a parabolic reflector at the back, if you go close to the coil, the intensity increase, but the area of the coil coverage, because of the parabolic converter is in a particular angle, that will narrow down. So when you move away from the coil, the light fixture, we will be able to bath the whole coil with the irradiation, but the energy intensity drops. So usually using the manufacturer's recommendation, we will be able to fix the exact gap between the coil and the lamp fixture. In the last few years, once we understood there is a need for airstream disinfection also, what has become popular is a 360-degree lamp. There is no back-end reflector used, as you can see in the right side photograph, and also pictorially illustrated in the above visual. So with a 360-degree lamp, what happens? all around the UV lamp in 360-degree, it illuminates and baths anything, everything in line of sight. So UVGI works with the principle of line of sight. Wherever the UVGI rays strikes, hits, that will be disinfected. Wherever there is a shade, it won't be able to penetrate and it won't be able to disinfect. So this way, we usually think of how to apply the design parameters, how to select the lamps. So whenever we try to do only coil in disinfection, we can go with a back-end reflector, because here the intensity required for the UVGA lamp will be relatively lower compared to airstream disinfection. And this is expected to be kept on a continuous basis. That is how the intensity could be lower. When we talk about airstream disinfection, usually we require high intensity. The idea is we want to disinfect the airstream just in a single pass. Now, if you look at the right side visual from ISHRAE handbook, bacteria and virus are very easily susceptible compared to a fungal spore. That is why we usually go for MER12, MER13 filters. The idea is we can easily trap the bigger size spores. Now, bigger size fungal and algae, they require very huge amount of dose. So let us first understand what is this dose. So the dose is the amount of irradiation that a particular microorganism has to be subjected to be able to totally get disinfected. So usually the dose or fluence that is defined, it depends on the intensity of the lamps times the seconds exposure. So that is how the dose is calculated. And the amount of dosage that we give to a microbe, it is also calculated in a mathematical manner, because we keep referring about logarithmic scale of reduction. Like we talk about 3 log, 1 log, etc. So how this is done is, for each and every pathogen, there is a particular K factor, which is called the species dependent deactivation rate constant. So this is computed through laboratory research, and using this formula, it is usually published, like D90 value is this much or D99 value is this much. Now, different researchers keep giving different values of dose and K values. This is a complex process, and usually many research papers give varying results. So we need to keep this in mind. And with all available information, we have to take a decision of informed choice of decision making. Let me move further and show a sample chart where one typical research paper has published the sort of D90 value of different pathogens. The font size is small and you may not be able to read each and everything that is here. But the second column talks which type of molecule it is, RNA, DNA, etc. You will be able to notice the UV dose for D90 in joules per square meter. So this is how usually the research paper publishes the value. Talking about COVID-19, COVID-2 virus, COVID, the currently there is a research paper published by Bianca and the team in 2020 last year. So far, what we were referring in all these handbook is a typical coronavirus. There are so many families of coronavirus. We were using that data. But last year, Bianca paper came out specifically with the dosage required for CO2. So looking at this chart, at the y-axis gives the percentage of survival, which is called S. In the previous page, we looked at the formula, the survival rate. So 10 indicates 10% survival rate. So the effectiveness, the kill rate is 1 minus S. So 90% disinfection possibility. So this we call as 1 log. So if we go down, 1% survival is log 2, 2 log reduction, which is 99% disinfection, and so on. This is how the logarithmic scale exponentially requires very high dosage of UV irradiation. So that still reduced to 450, 470, something like that. Very minimum exposure time required is about 0.25 to 0.4 seconds. So we calculate this particular time and establish for the required kind of dosage. If you take 3 log reduction of CoV-2 virus, this is the dosage required from Bianca paper. So we establish, do we have at least this much space in the air handling unit? If it is there, we can attempt airstream disinfection also with a 360 degree. There are many air handling units which may not have this space. Then what do? Then we can still do only a coil disinfection in the AHU, because we don't want to have a dirty coil and resulting in some other kind of infection, and then go for duct stream disinfection. So in a duct, we know the air velocity is high, roughly 3 times. So almost using the same design parameter, we can establish what is the length of duct that we need to irradiate with this particular amount of intensity, so that we saw the formula, the intensity multiplied by times in seconds exposure, that is the dosage required to neutralize, disinfect the CoV-2 virus. So this is a typical picture of a duct UVGI. It can be mounted in either way, either parallel along the airstream, or it could be mounted in a cross flow direction. The idea is, while designing, we will have to decide what is the length of duct we need to irradiate, and then we suitably decide the other. Just 2-3 more slides giving you some key information. In 1940 itself, the upper zone irradiation units were deployed in schools and colleges in US and Canada. So these are typical photographs, how it looks. It comes in different shapes, be able to cover large areas of rooms. This can be applied in non-conditioned space also. That is the beauty of these units. It usually works by natural convection current, as you can see in this picture. And if we can slightly run a ceiling fan in non-air conditioned space, it will provide some gentle air circulation. How this is designed is, the baffle design is very crucial here. These are hung from ceiling and mounted roughly 7 feet from ground floor, well above the occupied zone. The lures are designed in such a way, it deflects all the UV irradiation towards the ceiling. So near the ceiling, we build this 2 feet or 3 feet thick irradiated zone. So by natural convection or a slightly mechanical ventilation, we keep circulating the room air. Whatever microbe may be present in the room, by the time it goes and passes through the disinfection zone, it will get disinfected. This is how it works. Now, why we will have to be careful about the baffle design, and why it has to be above 7 feet, why the baffle should be focused towards the ceiling. The reason is, from the safety point of view, we do not want the occupied zone to experience any higher irradiation, because UVC is not, there is a limit up to which a human can be exposed. We are going to talk about that. So there are guidelines. So we do not want to have irradiation level of more than 0.1 or 0.2 microwatt intensity in the occupied zone. That is why we keep it above 7 feet. And compared to the AHU and induct airstream disinfection intensity, the upper zone irradiation units have lower intensities. That is how it is selected. It is a tightrope walk. There are many other applications of UVGI, like as you can see here, there is a mobile HEPA UVGI unit, which helps hospitals to convert a general ward into a negative pressure isolation room. So as you can see here in the illustrative picture, there is a HEPA filter used, then followed by a UVGI, then the blower motor is there. So this is how the UVGI is used, so that we don't end up contaminating the neighborhood with COVID patients inside and the exhaust air being infected. So UVGI now, there are quite a few manufacturers who also offer UVGI in a standard air purifier in residential commercial application. So in addition to dust level control, water control, we can also have pathogen control. The handheld disinfection unit that you see at the top right, this can be used for hotel room application, hospital application, any surface, maybe a bed, maybe any table surface, and there is no limit. Any surface that we doubt could be infected, we can simply expose the handheld unit. In less than a second, because these generate close to 20,000 microwatt, in less than a second, we will be able to disinfect CoV-2 virus. Portable in-room disinfection units, these can be used anywhere. Maybe generally this was designed initially for operation theater disinfection in less than 10 minutes, depending on the size and the intensity it generates. There are different models. A typical operation theater can be disinfected in less than 10 minutes so that more operations can be conducted without waiting for fumigation process and all that. Now, similar units can be put in a washroom or a big office, big hospital, ICU room. There is no limit. Only thing, whenever this is on, we don't want any people to be present inside. That much care we need to do. We have to follow the manufacturer guideline. There are also emerging technologies for disinfection. On the UVC, one technology which is emerging is LED lamps, which use 222 nanometer wavelength. Currently, what is available commercially are low intensity LEDs, which are not very useful just now for HVAC, but a lot of research is going on. Maybe next few years, we are going to see LED coming in for HVAC also. There are also other technologies like PCO and PHA, etc. These use UV of different band, different wavelength. Not necessarily every technology use UVC alone. They could use UVB or UVA, which depends on the catalyst used and the kind of intensities they want to generate. These products usually generate super rich oxygen ion and hydroxyl ion, which get attached to the aerosol, and that is how they disinfect. The effectiveness and the safety of these units are being researched, so we need to pay attention to that. On the safety, as I said, CDC, NIOSH, other organizations have come out with recommended exposure level. We have to wear PPE beyond that. If we are exposed continuously beyond the REL limit, it could be a little harmful to eye and the skin. And while disposing these UV lamps, we need to take care, very similar to whatever care we may be taking for fluorescent lamp disposal because of the mercury presence. But comparatively, the mercury level used is much, much lower compared to fluorescent lamp. If you don't want to use glass inside AHU or anywhere, because glass may break and we will have to deal with a broken glass, these low pressure lamps are also available with shrink fitted sleeves. So even if glass breaks, it will not fall on the floor. Material compatibility is one more thing designers have to keep in mind. There are a lot of research material and guidebook available. UVGI doesn't penetrate any material. It only gets reflected. It may react with elastomers and organic material. So whatever AHU gaskets, seals, etc. that may be there, we have to take care. So we need to check with the AHU manufacturers as well as the UV manufacturers. When in doubt, because we said it is a line of sight device, only if the UV rays reach, there may be a reaction. So whenever we have doubt, the best thing to do is simply shade it, maybe cover it with any material, and UVGI won't be able to penetrate. To conclude, UVGI is a well-proven, a very wise design approach to technology, which we can very easily incorporate. And there are quite a few ISHRAE publications last year and this year, which talk about a hybrid solution for IAQ using filtration technologies and UVGI. So this is well proven. Probably the next few years, we are going to see more and more futuristic IAQ designs, making the UVGI an integral part of the design solutions. Thank you very much, and over to Nisha. Thanks.
Thank you for taking us through the presentation on the position of UVGI. I would now request our moderator for the day, Mr. Vishal Kapoor, to please take over.
Thank you, Nisha. Thank you, Mr. Raghavan, for a very enlightening session. I know the time was short. You tried to do best to it, but we could all keep on listening because this is a very interesting subject, technical and very, very current in nature. So let's have a small panel discussion around it because we have some very, very distinguished guests along with us who want to be able to share their views and thoughts the opportunities, the challenges with UVGI. Everything is not as easy as it sounds. Is it really being done or not? So without wasting any more time, I'm going to be inviting all the panelists to come online. And the first I would like to invite is Dr. Avinash B. Kulkarni, a person who does not need any introduction in this industry. And nevertheless, I will still just read out that he is a BTech from IIT Mumbai, a PhD from the University of Pennsylvania, founder, director of Lightex Electrical, Lytle Infrared Systems, ArcLight Specialty Lamps, AeroPure UV lamp systems, a wide range of products, all kind of lamps from photocopiers to stage, studio lighting, halogen lamps, quartz, infrared, laser, quartz back MH, UV lamps, UV air purifier, UVGI devices, ozone-based odor control systems, and a host of UV disinfection systems. He's been very, very active in various societies like ELCOMA. He's been the president for a couple of years. He's been the president of IL for 4 continuous years. With ISHRAE, he is a distinguished lecturer and also a member of the TG on UVGI. So welcome, Dr. Kulkarni. It's great to have you on board with us today.
Thank you. My pleasure.
Thank you, sir. I would like to invite Mr. J. Sankareswaran on the screen in front of you. Mr. Sankareswaran, please, can I have his slide? Mr. Sankareswaran is the head of infrastructure projects at the Cancer Care Initiative, which is a Tata Trust organization running cancer hospitals with 10 in Assam and 5 pan-India, COVID hospitals, 7 completed and a few ongoing, veterinary hospital in Mumbai, community kitchen in Gadchiroli, infrared design for other livelihood projects. He's has also in the past worked as section head engineering and maintenance with the Geo World Center and a director of engineering with the Taj Group of Hotels in Chennai, OHL. So welcome, Mr. Sankareswaran. Good to have you on board with this session.
Thank you very much for giving me the opportunity.
Thank you.
To be here.
Next, we would like to call Mr. Rahul Prabhakar. Rahul is also a member of this particular TG on UVGI, an electrical engineer with the Delhi College of Engineering. He's been with the ITC Hotel since 16 years, various positions, including a 6 Sigma Black Belt specialist and energy auditor. Served as chief engineer of ITC Kakatia, Windsor, Moria, and currently with the Grand Chola. He's been instrumental in the above hotel bagging many prestigious awards and has also executed innovative projects in the field of energy management, air quality, water conservation, EHS, and sustainability. So welcome, Rahul, on board this session today.
Thank you, Mr. Kapoor.
Next, would like to invite Rakesh Bhatia, who's also representing the association Awesome. Rakesh is currently the Senior Vice President with EcoFirst Services Limited Mumbai, which is a Tata Enterprises. He is basically involved with business development for integrated design services, MEP services, sustainability services, renewable energy portfolio, energy auditing and retrofit portfolio. He's also been instrumental in designing the volume program for IGBC for retail chains and standardization of IGBC credit across various rating systems for easier market adaptability. His client portfolio is large. It's impossible to read the entire thing. He's been associated with the Orchid Hotel, Mantia Cardiac Hospital, Hiranandani Hospital, Trident Hotels, Chalet Hotels. So a very, very rich experience across healthcare and hospitality and into implementation. So welcome, Rakesh. Welcome on board.
Thank you. It's my pleasure to be here again. Thank you.
Thank you. And finally, our own dear Richie Mittal, immediate past president of ISHRAE, an engineer from BIT Mesra and an MTech from the Delhi College, director of Overdrive Engineering Private Limited, a company specializing in energy efficient design, passive and engineering air conditioning cooling systems, indoor air quality, geothermal, in energy audit, green building, third-party commissioning, and TAB. He is our immediate past president, a board director at IAQA, a director region at large with ISHRAE, and a patron of the BITOCA, which is the BIT Institute Global, along with being an HVAC consultant. So welcome, Richie. Welcome on board, and good to have you back.
Thank you, Vishal. Thank you.
So thank you, everyone. And I'm going to shoot off straight to some questions. I'm just going to request each one of you to try and say around 3 minutes so that we can have more and more interaction, more and more questions and answers, and also try and seek some audience questions. Audience questions have already come in the panel, so as and when anyone has time, we can also reply online on the chat box also. I'm going to hit off straight with Dr. Kulkarni, our senior most member, veteran in this whole field of lamps and UVGI. You're a pioneer in this line. It's great to have you on board with us. it's even better to have you as member of our technical group of UVGI because of the rich experience and knowledge you bring on board. Whatever the society does is going to carry a lot of weight and credibility, sir. My simple question to you, sir, you've been in this line of UVGI for many, many years. What has changed really, especially in the last year and a half, year plus, as far as applications go, as far as customer profiles goes? Has there been any changes that you're noticing as a manufacturer and a service provider?
There has been a sea change. Actually, when we started Aeropure UV Systems Private Limited in 2011, we were actually lamp people. We knew nothing about HVAC. So, but I read some articles about this UVGI and persistence system. Mr. Anand Deshpande, Dr. Anand Deshpande, gave me opportunity to do his headquarters. And when we did the UVGI in their HUs, we were shocked to see the tremendous improvement in the quality of air as well as the energy saving. And then I asked the permission of Persistent, can I publish the result? He said, go ahead. And then 2011, I made a presentation in Bombay, and the editor of ISHRAE was in the audience, Rakesh. And he came and said, can you write this up? And I was so glad that I got an opportunity to write a paper after quite a few years. And that paper, that work done for Persistent System Headquarters, gave us the confidence to start a new company. And the things have changed dramatically, because earlier all our cells were dependent on energy conservation. See, nobody really gave any importance to air quality. So the only way, and I think another very fortunate coincidence is that Delhi Metro came at the same time in the phase 3. And this was part of the specification in which all this underground metro station, you can just imagine what a huge HVAC installation it is. It's a couple of 100 millimeters long and massive diameter. The amount of air you are handling is colossal. So we were able to get there. We got the approval from UL approval. And so that established us in this field very solidly. Now we have also done some 20 airports also. But what has changed now, the last year was absolutely a dramatic change, because all the people were concerned about the air quality. And this has really given a big boost to UVGI. And here we are sitting, I think, largely because of what has happened last year. And so I think I feel this is a fundamental change, and this is not going to disappear with the COVID, because it's like water. 30 years ago, when we used to travel by rail, we used to just go and drink water from any platform. But now nobody does that. They buy bottled water. So this is similar change has taken place in this industry, and this is a permanent change. And the air quality is becoming more important. And UV is definitely a very important tool to improve the air quality and energy conservation. And I think one thing which is not realized here, that cleaning up those the mold and mildew, those themselves a source of microbes. Once you eliminate that, a major source of microbe is gone. And so when the air is going between the lamp and the cooling coil, even though the duration is short, but it says you got 10 air changes. So it's coming back again and again. So it is getting chance to get disinfected several times in an hour.
That's very important, Dr. Kulkarni, that you said that the journey of UVGI has happened from an energy conservation and going on to indoor air quality. And fortunately, people are getting knowledgeable and conscious about the kind of air they breathe, and this is going to stay. And that's why I'm going to just go on to Rahul next, because Rahul is wearing two hats. He is part of our technical group which developed this document, and he's also representing the hospitality industry, one of the biggest brands in the country and globally, ITC. And I wanted to understand from you, have UVGI technologies really found an application in hospitality industries? Because you still see a lot of surface cleaning, you still see air fogging happening. between room changes in public areas. Do you think UVGI has already found or is going to find a big application in the hospitality industry?
Thank you, Mr. Kapoor, for this question. So basically, specific to hotel industry, I just would like to take you back maybe 18 months back. What happened even before the pandemic struck? There were various types of hotel segment. One segment which were following green building guidelines related to installation of MERV 13 rated filters, and also hotel which were present in few cities having high air pollution condition, comprising of dangerous PM 2.5 levels, and have upgraded their system with high efficiency filtration system. Therefore, those hotels were having base foundation already built in to combat the current scenario. Then there was another segment of hotel which have installed the UVGI in their HVAC system for the energy conservation as well as for the infection control, but designed only for the surface treatment of oils. As advised by various bodies, and that UVGI or any other technology is not the 100% solution, as virus spreads through air and surface routes, and therefore mix of air and surface disinfection technology needs to be deployed at the shop floor to address the issue of SARS-CoV-2 virus. There is a good amount of time and a long debate on whether SARS-CoV-2 is airborne, starting from last July to 2020, when 200 plus scientists had written a letter to WHO. And finally, in this year, May 2021, when the Lancet study has concluded effectively for its predominant airborne nature. Also, we were witnessing that there were a lot of variation happening. Research papers were coming very frequently, almost every month. Some new study will come on. The whole fundamental from where the infection control approach have evolved is from the Wells-Rayleigh model. Now, Wells-Rayleigh model is there in the industry and been followed from, I think, 1955 onwards. And now, last month, I've seen one research paper which is again has changed that equation to suit the various filtration technology. Now, whether to design the UV design basis on the Wells-Rayleigh model, or you have to follow the CFD analysis, or you have to go by the manufacturer recommendation. So there are a lot of recommendations which are there in front of us. There are, as Mr. Raghavan explained in his presentation, that there are other factors like K factor changes depending on the variants, virus or bacteria. There were a lot of debate and research paper came out on UV dose as well. So 1 month we have seen one UV dose for SARS-CoV-2 virus, and another research paper saying something different. So almost 1.5 year specific to UVGI, there is a lot of information coming out, and obviously when the pandemic struck, hotel industry is the worst hit industry. Well, it is a very well known fact, and fighting for its survival till date. But going forward, the situation will improve definitely, and by now, all the hotel teams would have explored various options and would be sitting at tipping point for technology adoption. So UVGI would have a promising future in the coming months, what I guess. Thank you.
That's interesting to know, Rahul, that the hotel industries, yeah, they are struggling. They are going through a very, very tough time. But yes, they are wanting clients back and give safe air and that confidence to everyone. And they will be looking and are looking at UVGI as one of the possible solutions. And you also talked about a lot of changes that have come in the understanding, in the awareness, in the selection of UVGI, apart from what we've gone through, the whole aspect of the virus. So I just want to reach out to Rakesh in this point, because Rakesh is a consultant, has also served part of the user community from healthcare, hotel, and as a consultant today. What do you think is the biggest challenge while selecting and applying, a UVGI? And what are the myths or the limitations around UVGI that you see and you are of concern to you?
So what we've been finding in the industry is a lack of complete awareness. Like, I agree with Rahul that the hospitality industry is in the forefront of designing these solutions and trying and applying it within especially the grade 5-star hotels. However, what we've been seeing is that there is a lot of myths around this technology, and not only UVGI, even people are not even aware what are the basic requirements of air quality improvement or this kind of technology adoption. So we have to, along with this position paper, I'm sure it will highlight all the other areas of improvement also and the various filtration technologies which are available. Because first is creating the awareness and then bringing about what are the advantages, disadvantages which are applicable, and then carefully selecting the cleaning technology for as per application requirement. Now, also very important to note is that what we've been observing, especially since I've been doing a lot of commercial buildings where wellness is now a very important feature, because these grade A commercial buildings, there is a lot of high-end staff which is working in these buildings. So developers like the big REIT funds like Blackstone or the other REIT funds which are actually buying assets in millions of square feet, they are more worried about the concerns of staff safety and air quality improvement and infection control. So they have been quick adopters to this UVGI. And what I have personally seen, like in fact, I'm currently monitoring one of the better installations at one of the pharma headquarters in Mumbai at Lower Parel, which is for Cipla. Again, we are seeing that the adoption rate is quite fast, but they are always talking about hybrid models. So here again, the mix of MERV filters along with UVGI is catching up at a much faster rate, because I feel that some of the grade A occupiers are now much more familiar with these technologies going forward. Also, along with it, we need to have that culture of actually regular testing as well, because that has been missing. Just by adopting the technology and putting it in place doesn't help. So what we have been advising our clients is that dynamic sensors which give real on-time monitoring of all the air parameters, and then once in 3 to 6 months, the infection control surveys, all that needs to be carried out integrated. So it is much more a holistic process which needs to be adopted across the entire industry. Yeah, this is my take on it. You're on mute, Vishal.
Yeah, sorry, thank you. No, it's interesting what you're saying about combination of filters and reaching the end project. And I said at the beginning also that no one solution is going to give you the final result. It's always a combination. But reaching out to Mr. Sankareswaran, because you're part of the hospital, the healthcare trade, and traditionally, historically, for many, many years in India also, apart from world over, UVGI was more and more going primarily into the hospitals. It was going in, and hospital also was going in the critical areas like operation theaters and ICUs, etc. We were not seeing it being used otherwise. Now with the kind of pressure we're facing because of this virus, especially in the higher occupied zones like public areas like OPDs and clinics and waiting rooms, etc. Are you seeing hospitals demanding, designers, hospital owners, facility managers, doctors themselves demanding that make those spaces also safe and not just where it's a critical patient being operated or being treated?
Yeah. Let me first start with the first COVID hospital, which we started our initiative as Tata Group from Tata Sons as well as Tata Trust. We almost committed 2,500 crores towards the COVID initiative in the last year when the pandemic broke. And we really partnered with a lot of state governments. And then there was a quick response from most of the state governments, especially the first one which we did was the Delhi Noida hospital, which was readily offered to us, which was almost in the completion state. We took over that hospital and then we converted that into a COVID specialty hospital. And that time, there was no really clear idea of what is COVID all about, and then what kind of infection control and how it spreads and how long it lasts on various surfaces, and what are the really available technologies to control this infection spread, because you're going to potentially treat all the COVID patients who are highly infected or moderately infected or just diagnosed with COVID. So you have various, category of COVID patients. So how do you treat all of them, and then how do you control the air quality in and around the hospital environment? And anybody and everybody who's going to walk into the hospital is either a person who's already infected with COVID, and the people who are going to treat them, they are also very much afraid of whether they will also get infected with these people. So that's the kind of scenario we were challenged with, and we had to really seek a lot of industrial advice and expertise from various people, and reach out to the people who have been already designing COVID hospitals elsewhere in the country as well as abroad. So what we did exactly was we reached out to some of our group companies. We have inherent strength of Tata Projects and Voltas, who's also a HVAC company, and also we roped in some of the HVAC consultants like SNC from Delhi. So we did some little bit of research, and then we zeroed in on UVGI technology for infection control for a lot of reasons. And it is not only the air which is actually being pumped into the hospital which has to be disinfected. It is the air which is getting exhausted, the air which is getting recirculated. What is the kind of UVGI technology that we are going to adopt is what was the challenge. Then we went for duct-mounted UVGI lamps, both in supply air as well as in exhaust air. And while designing, as everybody said, the duct sizing, the lamp sizing, the kill rate, the wavelength, and what type of lamp, which brand, which gives us most maximum efficiency, and what are the kind of efficiencies these lamps have. So these were all analyzed. And then we decided that for ICU, we should go for 100% air, fresh air and 100% exhaust. And then we also had isolation wards, which are like, moderately infected patients. Then there we decided what is the percentage of recirculation of air which has to be there. So there again, we went in for almost close to 35 to 40% recirculation. Then we had also the waiting areas, OPDs, and everywhere we try to use the portable UVGI lamps. And these areas, OPDs, once the doctor finishes the consultation, the room will get emptied. So most of the areas where we wanted to use portable UVGI were like, places like operation theaters where we can just leave the UVGI lamp on for a few seconds or few minutes, and then we can remove it after that particular time period. So wherever there is an intermittent usage, yes, portable devices were explored, and also wherever there is a continuous occupancy, we went for duct-mounted solution. So that's how we handled the first hospital, and it received a lot of appreciation from both the government of UP as well as from our own team, and then we went ahead and implemented in 7 hospitals so far, whatever we have completed.
Very interesting to know that the usage of UVGI has gone outside just the critical area. It has gone to public areas, it has gone to rooms, it's gone everywhere else to keep patients safe and to mitigate. It's very interesting. And also Rakesh touched upon it in his talk also about this combination of UVGI with media filtration as being the one which is becoming the right solution possibly going ahead. So I want to reach out to Richie over here, because you are, and you've been one of the leading pioneers in the IAQ field in India across various applications for many years. And you've done a lot of implementations across categories of hospitality and otherwise. Now, there's a lot of myths saying that I might have a very bad filter, I've installed UVGI, I'm safe. So, can you say UVGI is really just a replacement of media filter to be used in combination? Also we've been hearing this talk of equivalent filtration levels being talked about, and we've had that session once in ISHRAE a month and a half back, talking about equivalent filtration. How would you like to talk about this combination, replacement, equivalent filtration?
Thank you, Vishal. I think it's a very important, and I think there are a lot of people who are looking this as an option. And at various societies, I will not like to name one, but there are a lot of research which is happening per se with a combination of various filtration with UVGI. There are a lot of studies now happening that, ISHRAE has spoken about MERV13. ISHRAE has also spoken about, filtration with MERV13. Now, MERV13 can be a combination of MERV7 plus MERV11 or MERV11 plus, some percentage of UVGI. Similarly, with MERV8, more percentage of UVGI can give you MERV13. So there are a lot of combination, and there are a lot of work which are happening on this front, where UVGI along with MERV filter is a combination which is happening to get you MERV13. But having said so, you think it's not a replacement of filter, no. MERV, any particulate filtration is also important. Like for that matter, HEPA filter is very commonly used in our most of the application with UV as a combination. So HEPA is going to take care of all the particulate, whereas UV is going to take care of all the pathogens. So we have to understand the combination, and I see a lot of air purifier which are now available, which has a HEPA filter along with the UVGI. And so there are various combinations which are available, and there is a research, as I mentioned, is going on combination of particulate filter with UVGI to get you a better filtration and the safe zone. I'm happy that we are talking about this air quality now, although pandemic has taken away a lot of lives and other things. It's still going on, but I think that's a new normal. We have to live with a good air quality and a good filtration. So I'm sure soon we will hear about a combination filters with MERV and UV plus HEPA plus UV. So that's what I would say, Vishal, at this time.
So basically, it also depends on the kind of pollutant that you're looking at to
Yes.
achieve that filtration level, because UVGI is not going to handle the particulate matter. It's only going to
Yes.
handle the microbes, etc. But for particulate matter, you could
Pathogens.
need media or whatever other kind of filters you would want to go in for. So with this UVGI thing, that's one question to Rahul. I'm going to request everybody to a little fast because we're going a little behind schedule, maybe a couple of minutes each on one question. Is there a selection guide that exists for UVGI or one that's going to come in? Because a lot of times we're seeing that we're going on a per CFM selection, or we're going on just as whatever the manufacturer tells us, really. There isn't a way properly for a designer, installer, buyer to, how does he rightly get the kind of UV lamp intensity, etc., that he has to buy? Is there a selection guide available or in the making?
So what I have done my research for last almost 1 year, and I have gone through one handbook called, I think published by Mr. Kowalski and published by Springer publication. So I think that is a book which predominantly all the UVGI industry follows as a base book. And yes, because the specific to SARS-CoV-2, still there are a lot of research going on, a lot of K factor and modeling, and a lot of things are coming up. There is a dire need for people like us who are from consumer industry to get one single document which will have the for the view of installer application, right from the design stage, how you design it for your FCUs to HDUs. So there have to be a book specifically designed for UVGI. Our technical group committee is also working on that part to design a ISHRAE handbook in the coming future. So hopefully the people in this industry will have a single point knowledge platform.
Okay, that's interesting. So hopefully very soon we will have this handbook coming out by ISHRAE, as you said, on UVGI selection, installation, etc. So, and lamps is the most important part of this UVGI system. So I wanted to ask Dr. Kulkarni, is there a certification like ISI, etc., that exists for lamps? Is there any standard which is there currently, which will help people choose the right product?
There is none right now. I've been member of International UV Association for almost 20 years. And they have methodology of measuring the output of UV lamp. But the specification, like anything like BIS or any American specification, to my knowledge, there are none. And so It is, but at the same time, there are very easy ways of measuring UV output of a lamp. If you have very good quality UV meter, you take a lamp, UV lamp, say the UV lamp is 1 meter long. Perpendicular bisector, you go about 2 meters away and measure the UV intensity. With just one measurement of UV intensity of a lamp, you can calculate the UV output of the lamp. And it is called Kite's formula. And this is endorsed by the International UV Association. They have carried out this test with 8 or 10 different companies, and they have all agreed, unanimous opinion. So this Kite's formula is something of a very important nature. Not only that, it also gives you intensity of UV at 1 meter length. This is something which has been agreed by the industry, that we will not only give the UV output, but we will also give UV output, UV intensity at 1 meter distance from the lamp at right angle bisector. So as I said, if you just take, if you have a UV meter, good quality, calibrated, traceability, with traceability, a good UV meter, and just measure the intensity at double the length of the lamp, and you get all the important parameters of the lamp. Another thing which is very important is what in our position paper, we have made it very clear, is the effect of temperature. Now, if somebody goes and buy a UV lamp, as of now, even 80% of the lamps go into water disinfection. 75–80%, maybe now things are changing a little bit towards air disinfection. So they are designed for say 30 degree for 25 degrees centigrade. And as you know, if you go from 25 degrees centigrade to 13 degrees centigrade, the efficiency may drop by 40%. And we do these measurements at different temperature. And so our lamps, so the lamps for UV, for UVGI, for air, for HVAC are quite different, and people don't understand this. And so it's a very important factor that if you take the regular lamp available off the shelf, you are not going to get the results what you are looking for.
Okay. Thank you very much, Dr. Kulkarni. Thanks for letting us know on one way of checking the correctness and the applicability of the correctness of the UV lamp that you're buying, because with this technology becoming more and more popular, there are more and more manufacturers, more and more companies that bringing on the product, and it's right and important for the end user, the installer, to know that he's buying the right product and not just getting fooled by so many technologies coming in. And I just want to reach out to Mr. Sankareswaran on this aspect, because Mr. Raghavan covered it in his presentation to some extent on the safety issues around UVGI, for whether the installer, handler, or whether the occupant of the room. You think people are conscious, people are aware of the safety issues and how to handle UVGI lamps?
Yeah, let me first start with what are the potential hazards associated with UVGI lamps. If you do understand what are the potential hazards, then only you will understand what are the safety precautions that you need to take. So first potential hazard is like direct exposure of UV light to cause of eye damage. Second is exposed exposure, continuous exposure to UVGI, which can cause skin damage and skin cancer disease like that. And third is the breakage of the UVGI lamp itself, which can cause mercury spill. And there can also be some electrical damage if the lamps and holders are failing. So these are the potential hazards that you have. And for as far as you to protect yourself and safety precautions, first of all, limit switches, occupancy sensors, these are some of the protective devices that you can use for avoiding direct exposure whenever a person is entering a zone or using an equipment which is fitted with UVGI lamp, or accessing an AHU which is fitted with a UVGI lamp for servicing or other things. So whenever you open the access door, it should be fitted with a limit switch which can automatically turn off the UVGI lamp. So that is something which is very important. And an area which is getting disinfected with UVGI lamp when it's not occupied. If somebody walks in, if it's with a motion sensor or an occupancy sensor, which can automatically turn off the UVGI lamp, that is well and good. And that reduces the exposure of human beings to the UVGI direct radiation. And coming to PPEs, yes, while installing UVGI lamps and while testing UVGI lamps, yes, technicians need to follow all the safety regulations and start using the PPEs as well. And you can also choose UVGI lamps with quartz sleeves, which actually covers the entire lamp and the holders as well. And which is also designed to the international standard, and you can follow G214 or 219 guidelines. Most of the manufacturers, lamp manufacturers, they follow that. And this will really help in avoiding the mercury spillage in case of the lamp burst or the damage. So these are some of the safety precautions that you can take to ensure that you don't get continuous exposure. There is no mercury spill, and reflectors and louvers, yes, of course, are there beside along with the UV portable devices or whatever it is. So
thank you. So that's good to know that there are a lot of safety points that we can implement to ensure that the exposure is limited or not there at all, and handling with PPs, etc. But there's one question that keeps on propping up is of ozone. Ozone suddenly become a very big word now, and people ask that what about the ozone generation that comes out from UV lamps? So Richie, you are the best person to address that. You know, what is it around UV and ozone, and is it really there, or what is it?
So Vishal, I think you are right. I think it's a very sensitive matter, and you know, there are so many technologies. You know, we divide it into active and passive. When I say passive technology, we talk about particulate matter basically, or UVGI may also be called in as a passive technology. Whereas an active technology is where you're using power actually. So you know, the power, wherever you are using the power, the ozone is generated. You know, if one says that it is not generated, that is not right. I will say so. But we need to limit it within, you know, UL, there are UL standards available, and it has to be within the limit. But, you know, if for that matter, there are so many technologies which are emerging technology, which has been rated as emerging technologies by CDC or WHO, which say that these are emerging technologies whose efficacies are yet to be established. So ozone is generated, and you know, there are other byproducts. I mean, why talk of ozone? There are other because an oxidation process, because there are 3 O's which are moving in the system. So any of the O can generate, combine with another 2 O's and can form ozone. So Vishal, I would say that one has to be a little cautious on that to understand of the ozone. It's a very well talked about, but there are standards of limits available with as per UL on any application where you use it. Sure, that's what
about ozone from UVGI?
I would like Dr. Kulkarni to answer that. I will not answer that question.
Waiting for an opportunity to answer that question. See, we have been manufacturing UV lamp, both ozone forming and non-ozone forming, for last 16, 17 years. We have made, at least we have exported more than meter long lamp, more than 500,000 or so to USA. I can say that with titanium dioxide doping in quartz of 200 ppm ensures that there is no ozone coming out of the lamp. See, in the mercury discharge, you have 2 resonance lines, 185 nanometer and 253.7 nanometer. Now, when it is a soft glass absorbs 185 nanometer, there's no problem. But with quartz, with 200 ppm of TiO2, it completely blocks. And since we manufacture hundreds of lamps per day, we will know it right away. If it is producing ozone, the person who's lighting up, testing the lamp will know. It has never happened in our experience the last 16, 17 years. It has never happened. So the ozone 185 nanometer is a part of the emission from the discharge, but it is absorbed by the outer jacket and it doesn't leave that. And I just want to make one more point about ozone is also, our nose is very sensitive. Our ozone safe limit is maybe 100 ppb, but we can smell ozone at 25, 30 ppb. So it's not, this dangerous limit is way above our sensitivity of our nose. So that's also a factor which helps us to make sure that ozone is not really playing any bad role in your system. And I'll just like to make one comment, which I think part of our the document which we have produced has that it is much better to have a Teflon sleeve on the lamp instead of quartz tube, because quartz tube is as brittle, as vulnerable for breakage as quartz lamp. But once you put a quartz sleeve, the transmission of quartz sleeve is like 95%. And if the lamp breaks, not only it prevents mercury from coming out, but the entire glass debris also stays inside. So this is a better solution, which is fortunately also already part of our document, which we have put together.
Thank you, Dr. Kulkarni, for clarifying this about ozone and how it can be limited, how it can be stopped from spreading into the occupied zone. So thank you for clarifying that. And I'm going to have my final question is to Rakesh. I wanted to have the most controversial question for you, Rakesh. So the question is very simple. There are, in the last year and a half, I think we've seen more air purification technologies, companies, brands, solutions come out, which have existed ever since we know about this subject. Without naming technologies, what is your take on this? How does the customer, how does the user, how does the designer finally get to choose what is the right air purification technology that he should use?
I would again come back to the first principles that going by the current trends, we never recommend any one type of fixed technology. Looking at the applications, what I would say is that there is a hybrid way of doing things. So we would rather combine passive and active ways. We would also look at the use of plants, natural ways, then combine it with MERV filters, and then depending on induct solutions or airstream solutions or upper installation solutions. So all put together, there are various ways to achieving the same objective. However, the myth needs to be removed that how is it that each technology is differing, and then what are the pros and cons of each one? Yeah.
Okay. Thank you.
I answered it non-controversially.
Yeah. I was wanting more controversy from you, but we are short of time. Otherwise, I would have prodded you on a little bit more on this. But we are running a little behind schedule. So thank you very much, Dr. Kulkarni, Mr. Sankar.
Can I just couple of comments I want to make? Can I just?
Sure, sir.
Very short. I just wanted to know how things. First question you had asked me how things have changed. When we started our new company Aeropure with UVGI as a prime product, we used to go to hospital, and hospital will say that our air is perfect, and so there is no question of so we had to tell only on the air, on the energy conservation. Second very important thing which people don't realize is once you put UV, once you expose the cooling coil to UV, the distance between those aluminum fins is less than a couple of millimeters. And it's hard to believe that it may take 2 years for it to clean the entire depth of the coil. Because what happens, initially the UV is only on the front end. And so once it cleans, it's aluminum, it becomes good reflector. And so it may take even a year or two to really penetrate the entire cooling coil. And third point I want to make, since I think all of us are recommend that please Google KITES formula, KEITZ, and please use it, because this is really a wonderful formula for testing the UV lamps, the output of a UV lamp. That's all I want to say.
Thank you, Dr. Kulkarni. Thank you, Mr. Sankareswaran. Thank you, Rahul. Thank you, Rakesh. Thank you, Richi. for being part of this panel today and sharing your thoughts and opinions on everything about UVGI. It is an interesting subject. Air quality itself is a very, very interesting subject, a very current subject. And I'm sure the years and the months ahead is going to throw out more and more research and more knowledge about this and help us take better decisions going ahead from and showing the air we breathe is good, safe, and healthy for us. So thank you very much. And I'm going to hand it over back to Nisha to take us for the last few minutes of this session.
Thank you, Mr. Vishal Kapoor, for moderating the session, and thank you to all our panelists for that wonderful, enriching session that we had. I'd now like to introduce and welcome our TG chair for UVGI, Dr. Nitin Deodhar. Could we please have the bio up? Thank you. Dr. Nitin M. Deodhar has a PhD from IIT Bombay. He's a mechanical engineer from REC Bhopal, a lead accredited professional from USGBC, energy manager credited of BEE Government of India, the chief designer of NM Deodhar Consulting Engineers, the managing director at Vision EMC Private Limited. He's been a past president of Pune chapter, the current chair for UVGI TG, and the founder chair of research in ISHRAE. May I please invite Mr. Nitin to take us through the process that went into this position paper.
Thank you, Nisha. I'll not take much of time now. We're running short. We need to do the main event of today. That's the launch of the position paper. Our National President Amitabh discussed, and Vishal Kapoor also talked about ISHRAE and the technical committee and the TGs. I would like to discuss and talk about the TGs in particular. So first, when a TG has to be formed, any member from ISHRAE can send a request which goes to the ITC, and ITC then decides whether it falls into the domain where ISHRAE needs to do some work. ISHRAE shall then appoint a chair for this TG. For example, the current position paper that ISHRAE is going to launch in your presence is under the aegis of the UVGI TG. So each TG can have any number of members. However, every ISHRAE member can opt to be part of a maximum of 3 TGs. Each TG will have permanent and provisional members as of now, but this might soon be modified. Amongst permanent members, each TG will have 5 voting members. Each TG can opt to have a co-chair. The advantage of having a co-chair is to have a clear succession plan. After the tenure of each voting member of 2 years, he or she would remain a permanent member, but a new member from the permanent TG membership would be elected as a voting member to replace him or her. As part of any TG, a voting member or not, one can participate in all general meetings of the TG and as an expert be part of an influential voice at the national and global level. If you're a beginner, as a TG member, you can get involved in your domain of choice and closely witness the trend, growth, and the pace of technology change in the field by simply attending these meetings. I would request all viewers to log in today after this program and be part of this powerful platform of TGs. You may join up to 3 TGs out of those listed in our website. The next part of the process after the TG is formed is forwarding the knowledge in our field of expertise. Our TG decided to start the process by releasing a position paper on this topic, which we felt was very important in today's context of the virus disinfection technology. This position paper by ISHRAE is a compact document which talks about the technology and application to disinfection in particular. This position paper has been written by experts from the field. You already seen Dr. Kulkarni and Mr. Raghavan. They represent the manufacturers. Mr. Bhushan Desai of TCS and Rahul Prabhakar of ITC Hotels, they represent the users. Mr. Ramchandran was part of this committee. He represents the consultants and the designers. I myself am a designer representing that segment. Richa Mittal, who represents a wider cross-section, a designer, a policy member, amongst others. There are several other members also who contributed to this document. The final version of this document was peer-reviewed by several experts from allied fields, and all their inputs have gone into making this document complete. I would like to thank not only those from the UVGI TG, but also those who committed to improving this document. Needless to say, our ISHRAE back office team, including Kundan, Jitendra, Ravi, and our publisher designer, all have put in huge efforts to make this document from a Word document to a publishable book. Lastly, I would like to mention that unlike a peer-reviewed research paper that gets accepted and published and remains as is, our position paper, like all other ISHRAE documents, is dynamic. Dynamic means after a specific time period, it is expected to be reviewed and upgraded if required. So after this launch is complete, I would request all of you to please download this paper, download this book from our website. You can get connected with our TG in case you want to know more about our future work plans. And as Rahul and some other members in the group discussion mentioned, we are discussing about a detailed handbook on selection of UVGI, which is being planned. There are some other activities also being planned. So that's all that the process of publishing this document which has gone into the entire work done till now. Nisha, I would request you to carry out the honors of beginning the book release function.
Thank you, sir. Thank you for taking us through the process. We will now move to the much awaited moment, that is of the launch. And for the same, I would request our National President, Mr. Amitabh Basur, Dr. Nitin, who's already here, Mr. Ramachandran and Mr. Bhushan Desai to please join us. Could we now officially launch?
I will request all of you to visit ISHRAE website, that is ishrae.in, ISHRAE.in, and download this document.
Thank you. Thank you, Amitabh sir. We've now officially launched the paper, and like sir mentioned, we request you to please visit the website ishrae.in, and you may download the same from the header. This paper is free to all our members and non-members. So thank you for your support. Thank you to everybody who has joined us this evening. I would now like to request Mr. Ramachandran to address the vote of thanks. Before that, I would like to read out his bio. Mr. Ramachandran is a mechanical engineer from College of Engineering, Trivandrum. He's worked in all areas of AC&R, such as manufacturing, sales, commercial projects, service and consultancy for the last 33 years. He served as director and associate consultants with AK Sham Consultants Private Limited, Mumbai. He's a presidential member of ISHRAE. He's part of the technical committee and the technical team coordinator for UVGI TG. I would now request sir to please share the vote of thanks.
Thank you very much. Before I do my assigned duty, I have one announcement to make. See, this technology which was presented to you today, the UVGI, is going to assume more and more importance as we go along, not only from the air cleaning perspective, but also from control of infection, killing of pathogens and all that. We are now come out with the position paper, and we are, as Nitin mentioned just before me, we are started working on a comprehensive handbook on UVGI. We have already circulated a message to all the ISHRAE members, inviting them to be part of this particular TG. After this meeting, we are going to send invitation to all of you who attended this meeting, requesting you whether you are interested to become part of the TG. Those of you who have got professed experience in the field will be taken as full-fledged members, and people who are freshers want to know more about the subject will be kept on a list and will be appraised of whatever developments the TG is doing. Now, before I thank anybody else, I need to thank two people, that is Mr. Bhushan Desai from TCS and Mr. Raghavan from JCI, who have worked on this particular position paper. Actually, the framework of the position paper and the initial input was given by Bhushan, and Raghavan subsequently worked on that and made it in the form which you are seeing today. I should also thank I should once again thank Raghavan for giving a very comprehensive and concise view of the position paper in his nice presentation today. Now, I should thank the panelists, starting with Dr. Kulkarni, Mr. Rahul Prabhakar, Mr. Rakesh Bhatia, Mr. Shankareshwaran, and Mr. Richie Mittal for giving us a very nice panel discussion. Not to forget our inevitable moderator, Mr. Vishal Kapoor, who kept the interest alive all along. Last but the most important, I should thank each and every one of you who have been here throughout this session and encouraged us with your presence. Actually, the position paper is dedicated to all of you. Without you, there is no position paper. Thank you very much.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir, for your kind words. We'd once again like to thank all the participants who joined us this evening. Have a good day. Stay safe. Thank you.